So chapter 8 is another important chapter in your final exam. So today we're going to start the 8.1. We will talk about some basics for the general hypothesis test. So in this section, we will talk about the key concepts of the hypothesis test and some key components of the hypothesis test. We will also talk about the general procedure of the hypothesis test. And in later section, we will focus on talk about the hypothesis test about the proportion and the hypothesis test of the mean, and we will not talk about any hypothesis test about the standard deviation or variance. So first of all, we should know what is the hypothesis test. A hypothesis is just a claim or statement, but this statement is about the property of the population. So make sure you understand. You are testing the property of a population. So if we should use the notation to represent the property of population, make sure you use the notation of the parameter. So it's just like mu p. Okay, it's just mu p in your hypothesis because it's just about the population. All right, hypothesis test is just a test. It's just a procedure. We will test the claim, the assumption, the statement, if we will reject it, if we will fail to reject it, something like that. So let's check the example. The example here is, let's check the title of the example here. We have this sentence. Majority of customers are not comfortable with drone deliveries. So this is the title of this example, and we will realize this is just the claim we have. Let's check the example. We know we have 1,009 customers. They do the survey. They were asked the question, and they were asked the question if they are satisfied, they are comfortable with the drone delivery. And 54% of these 1,009 customers responded with no, means they do not feel comfortable with drone delivery, right? How can we get to 54? Because we know 545 customers responded no out of 1,009 customers. So this is how we get the proportion of the customers not satisfied. 545 people says no over 1,009 customers. So this is just our p-hat. This is from our 1,009 customers sample. This sample is big, right? Because we have 1,000 customers. But this is still the sample, so we use p-hat to represent the proportion because it's the sample proportion. Then we go back to check the claim we have. We just have the sample proportion, but we want to make a conclusion. We want to make a conclusion about the property of the population. We cannot directly use this property from sample to make the conclusion about the population, right? So that's why we should do the test. We should test if we can use this sample property to get the conclusion of population property. So here, the claim we have is majority of customers are not satisfied. So we want to translate the words into the symbolic form. How can we translate the word? Majority of the customer. So that means most of the customer, or we will say more than half of the customers. If it's more than half, how can we express it by using the proportion? More than half, right? More than half So if we translate majority to more than half, next we know if we want to use proportion, so the proportion more than half. So P is greater than half, 0.5. This is called the symbolic form of our claim. So let's check the example again. We know we total have 1,009 customer, right? If we get the result something like 506 customers said they are not satisfied, can we know? Can we say we safely conclude the majority of the customers are not comfortable with that? Of course not, because the proportion in our sample is very close to half. It's very close to half. It's not very high, right? It's 50.1%, so it's almost equal to half. So we cannot say it's a significantly high result, even though we do not know anything about the statistics, because we know this one is close to 50%, so we cannot safely conclude this one is high enough to guarantee majority of the customer are not satisfied. But if we have this kind of extreme result, we have 1,006 customers out of 1,009. So which means the proportion we get here is 99.7% of the customer responded no. Can we safely conclude majority of the customer are not satisfied and not comfortable? We will say yes. Just use the common sense, because this proportion is very high. It's more than 99%. So we can safely conclude majority of the customer are not satisfied. But the problem is, in our example, we did not get the extreme result. This time we only have 54% customers responded no. But we want to know in the whole population, can we say majority of the customer are not satisfied with that? If you didn't know anything about statistics, you didn't take this course, you will say yes, because we can do the comparison, right? 54% is greater than 50. So we will say yes, majority of the customers are not comfortable. But do you remember what is this 54? This is just from the sample. But we want to get the conclusion about the whole population. So we cannot just use the sample proportion 54 to get to the conclusion about the population proportion. So if you learn something about statistics, you will realize you should do the test. You should do the hypothesis test. Then you can get to the conclusion. Of course, we can always use the technology to do the hypothesis testing. But in our class, we will not focus on this part. But in your future study or work, sometimes you check the output. Make sure you find some important values in your output. When you do the hypothesis test, these two are the most important parts. They're called the test statistic and the p-value. So here, we also have test statistic p-value. Every output should contain these two important values. So, of course, you could use the technology. And because the hypothesis test also called the test of significance. Remember in the chapter 4.1, we talk about we could use probability to determine one value is significantly high or significantly low or not significantly at all. So here, they are just the same thing, same significance. okay? It's still about significantly high or not. But this time we're talking about to use the test. But we still use the p-value to make the decision. Go back to the hypothesis. We have two kinds of hypotheses. If you do the hypothesis test, you will always have two kinds of hypotheses. The first one, H sub 0, we call it non-hypothesis. We call it non-hypothesis. And in this non-hypothesis, the only possible sign is the equal sign, okay? So that's the most important part. The equal sign is the only possible sign in your non-hypothesis, okay? So that's called a non-hypothesis, one choice. Let's check another hypothesis called H1, H sub 1 or H sub A. This one we call alternative hypothesis. But in your alternative hypothesis, you have several choices. It's possible to be the less than sign. It's possible to be the greater than sign. It's also possible to be the not equal to sign. Sometimes we get less than, sometimes we got greater than, sometimes it's not equal to. And less than, greater than, we call it a one-tailed test. Not equal to, we call it a two-tailed test. We will talk about it a little bit later. So this is the general procedure for hypothesis test. General procedure. So first, in your background, when you do the hypothesis test, you should figure out which sentence is our claim, right? You should find which sentence is the assumption or the statement. Then try to express it in the symbolic form. So first, identify the claim. Second step, give symbolic form. Step 3, we should determine which one is our alternative hypothesis and which one is our non-hypothesis. None and alternative. We should list, by step 3, we should list what is H sub 0, which is H sub 1. Okay, then step 4, we should select significance level. Significance level is called alpha. Is also called type 1 error. Maybe you will hear that word, the type 1 error. So this is also called significance level. This value is given by the question. In your question asks you to set the significance level as 0.05. If the question didn't mention that, the default significance level is always 5%, 0.05. Okay? If the question didn't tell you the significance level, then we use the default one, 0.05. And the two most common value of alpha is 0.05 and 0.01. So next step, we will try to find what's the test statistic by using the correct formula. Sometimes it's the z-test, sometimes it's t-test, because we do not talk about the hypothesis test about variance, so we only have t-test and the z-test. Okay, after we have the test statistic, then we have two methods. One called the p-value method. If we pick this p-value method, we're going to use the test statistic from step 5 to find the p-value by checking the table. After that, we use that p-value to make our conclusion. So if p-value is very low, something like less than or equal to alpha, then we will reject our none. If p-value is greater than alpha, it's big, then we fail to reject. If we reject none, that means we got a significant result. If we fail to reject none, which means we get a not significant result. So of course, we can use the critical value method. Okay, when we talk about critical value method, by its name, we should find the critical value. Then we compare the critical value to the test statistic. We also need a test statistic from the step 5 and compare test statistic to the critical value. Then we can make the conclusion. So here, the conclusion set is the test statistic is in the critical region. If it's in the critical region, then we reject. If it's not in the critical region, we will not reject. Later, I will give you another criteria, more easy to understand than this one. So the last step after we get the technical conclusion, something like reject none, fail to reject none, last step, we always need to give the non-technical conclusion, because the non-technical conclusion to help the people without any statistic background information still can understand our result. So let's talk about confidence interval method. So I will say we will not recommend the confidence interval to do the hypothesis test, because sometimes confidence interval method will get the different result as the previous two methods, p-value method and critical value method. So this confidence interval method is not very reliable, especially for the hypothesis testing about the proportion. Sometimes they will get the opposite result. So I will say confidence interval just for estimate. Confidence interval for estimate, but the p-value method and the critical value method to do the hypothesis test. So you can just ignore this slides. So this one is still the general procedure to show you step by step. It's just the same one as this one. It's just the same thing. It's just show you step 1, step 2 again. Okay. So let's check the example drone delivery. So we follow this step. Step 1, we're gonna find what's the claim, right? We already know the claim is the majority of the customers. So we find that sentence is the claim. Then second one, we try to give the symbolic form. We already know the symbolic form will be more than half, so that will be our symbolic form. The proportion is greater than half, it's more than half. So this is the symbolic form of our original claim. So next step, we should determine our none and alternative hypothesis. We check the symbolic form we get from step 2. We know this one must be one of our hypotheses. One of our hypotheses. So the question is, this is our none or this is our alternative? So which one? None or alternative? Think it over. Did you remember what is the none? The only possible sign in our none hypothesis is just the equal sign. But this time it's not an equal sign, so this is not our none. If it's not our none, it's our alternative, okay? So how can we write our none? So the only thing we need to change is just change the equal sign in the middle. That will be our none. So it's not hard, right? We keep P. Keep the value 0.5. We only change the sign in the middle to the equal sign. So that one will be our none hypothesis. So by this step, we have our none and we have our alternative. Maybe my method is a little bit different from the textbook, but I think I prefer my method. It's easy to understand. Okay. Again, you list the symbolic form of your original statement, original claim. Then you pick this one must be one of our hypotheses. So here it's greater than sign. This is our alternative. And we just change the sign in the middle to get our non-hypothesis. So let's check the alternative 2 again. This time the sign in the middle is greater than sign. You know, we have several choices in our alternative hypothesis. Sometimes it's less than, sometimes it's not equal to. This time we got greater than, which means this test is called right-tailed test. Right tail, greater than right tail, less than left tail, not equal to, called two-tailed, because we do not know the direction. Not equal to, it can be less than, it can be greater than. So it's called a two-tailed test. So by step 1, 2, 3, we know we have this symbolic form, and we will have this as our alternative, this as our non-hypothesis. So next step, we will set the alpha level. Alpha level is the significance level, also called the type 1 error. This is the meaning of type 1 error. The probability reject none when none is true. So this is called error. If none is true, we are supposed to fail to reject, right? But it's true, we still reject it. So this is called error. And this error has a name called the type 1 error. We use alpha to represent the probability of mistakenly rejecting the true none. So this is called the type 1 error. And this alpha level is given by the question. Question will tell you what's the alpha level. If it doesn't give you the alpha level, we use the default alpha level, 5%, 0.05. So here, common choice 0.05, 0.01. Okay. So I would say the default value will be 0.05. Step 5, we should determine what is the relevant formula. What is the test we're going to use? So find the correct formula to help us calculate the test statistic. So if it's the proportion, we're going to do the z-test. If it's the mean, so it have different situation. If sigma is unknown, we're going to use t-distribution, so we're going to use the formula with t. If sigma is known, very rare, we should use the z-distribution, so we should pick the formula with z. We will talk about it later. So let's check this table. If we are doing the hypothesis test about the proportion p, so it's just one choice, normal distribution, so C distribution, and we should pick this to get the test statistic. This is the only possible formula. Because this Z is not the critical value Z, I prefer to put a star to remind myself this is a test score. This is the test result. It's called test statistic. But in 8.3, we will talk about the hypothesis test about mean value. Then we have two different situations. Just like when we constructed the confidence interval for mu, if sigma is unknown, most of the cases are this one. So we will use t distribution. If we pick t distribution, so we will pick this as our formula to get to the test statistic. So I still put the star here. So I will remind myself this one is the test result for the test. So if sometimes, very rare, sigma is no, then we will say we will go back to use the C distribution. So we're going to use this C formula to get to the test statistic. So you should remember, if you have S in your formula, you must use the T. If you have your sigma, then you must have Z. Okay, and we do not talk about standard deviation. So this is just talking about the requirements. Okay, so in this case, both requirements are satisfied. So next step, we're going to pick two methods. We could use the test statistic to find the p-value. So that means we should use the p-value method to make the conclusion. Or we use the test statistic and find the critical value. Compare the test statistic to the critical value. We can also make the conclusion. So different methods. They always get the same conclusion. So test statistic, this is the definition. This is just the value to make a decision in your hypothesis test. So here, we only talk about the two test statistic, Z and the T, because we will talk about chi-square. Okay, so for this example, we are doing the test about the proportion. So if it's proportion, we only have one formula, right? It's just Z. So this is the formula. The question is, when we check the numerator, we have these two terms. The first one called p hat. So we already know how can we get to the p hat? It's the sample proportion, right? From the sample, we can easily get the sample proportion. Use X, how many customers said no, divided by the total number of the customers. So we get 54% as our sample proportion. The next term should be the P. Some students get confused. Can we know the P? Where is the P? Because the question didn't tell you that. So I will say the P is always from your hypothesis. Remember, what is your hypothesis? It is non-hypothesis as P is equal to 0.5. So that will be your p-value here. Directly from your non-hypothesis. Your non-hypothesis gives you this assumption. P is equal to 0.5. So we're going to use that value into your formula. The remaining part is just plug it into the numbers, but make sure you know the denominator here. In the square root is P times Q, not P hat, Q hat. Remember when we try to do the confidence interval for proportion? We have the square root in your formula too. That time, that one is the P hat, Q hat. But this time, it's just the P times Q. So here, we know the P is 0.5, of course. And 1 minus 0.5, we got Q. It's also 0.5. So I would say I prefer to give it a star. Give it a star. Maybe here, maybe here. Doesn't matter. So to remind myself, this is the test score, test statistic for the hypothesis test. So we will talk about the critical region, also called the rejection region, because we're going to use critical region to make our decision when we use the critical value method, right? So which the critical region means if the test statistic fall in this region, then we will reject it. If it's out of this region, we will fail to reject it. So let's check the graph to help you understand what's the reject region, critical region. So the green shaded part will be the critical region. So this is the two-tailed test. If it's a two-tailed test, then we will have two-tail reject region. The blue, the green left side green one and the right side green one, they are both reject regions. So if my test statistic Z, for example, for in this one, this test statistic with the star, for in this region, then our conclusion is we should reject. If it's in this region, okay, we will also say we reject. But if this Z is in here, then we will say we fail to reject because it's not in the reject region. It's in the yellow part, right? So similarly, for the left tail test, we only have left tail region to reject. One region, we reject region. Right tail, right side, reject region. One reject region. Critical region also. So again, two-tailed, two reject regions. One tail, one reject region. Of course, another method called the p-value method. So we should be familiar with the p-value method because in the previous chapter, we are talking about how to use the table to help us to find the p-value, right? So here we're going to use the test statistic to find the corresponding. Test statistic will be a z-score or a t-score. Then we use that z-score to check the z-table to find the p-value and the t-table to find what's the p-value. Then we can use this p-value to compare to our alpha value. So in this case, we know this z is our test statistic. So I would prefer to give it a star. Test statistic and use this z. I can check the table. You will find this as your p-value. So p here, we always use the capital letter p. Don't mess up with the lowercase p. Lowercase p is the population proportion, but the p-value we use the capital letter p means the probability, okay? And we compare the p-value to the alpha value. So it's less than 0.05. Obviously, it's very small. It's less than 0.05. So our conclusion will be we should reject our none. So let's check this p-value. Let's check right tail test first because our example is a right tail first. Right tail test. Remember what is right tail? Equals some value, right? But our alternative p is greater than. So it's greater than, so we know it goes right. It goes right. So right tail test. Let's check right tail first. So we could use the test statistic. Then the p-value is just the right tail. We could get our conclusion. If p is less than or equal to alpha, then we reject our none. So similar for the left tail. What kind of test we will say the left? For example, this time we have this hypothesis. So remember, the none is always have equal sign, but this time the alternative we have the less than sign. Less than sign. So this time, this one called the left tail. This is just an example of the left tail test. it's have the less than sign. So we could still use the test statistic to check the table to find the p-value, okay, the probability value. Then we compare it to the alpha. We will get the same conclusion. If p very small, then we will reject. Of course, if it's not less than or equal to alpha, we will say we fail to reject. But how about the two-tailed test? What kind of test we will say two-tailed? So equal sign in your none, it always that case. But this time in your alternative, we have not equal to some value. This time we do not know the direction, so we call it a two-tailed test. Two-tailed test, you check your table to find the value, the area in your table. But this time that area is not directly the p-value, because this time p-value have two-sided, two-tailed. So you should twice the area from your table, twice the value from your table. Area means the you check the table to get to the area, okay? Area, of course, this should be the area cumulative to the left. Twice the value from your, twice the area you get. Then that one will be your p-value. That one will be your p-value. You use this one still use compared to the alpha. And if it's less than alpha or equal to alpha, we reject the null hypothesis. So the rule is always the same, but the only difference between two-tailed and the one-tailed test is the area. For one-tailed test, the area is automatically, it's the area to the left is already the p-value. The area to the left is already the p-value. But for the two-tailed test, the area to the left should multiply by 2. That one will be your p-value. Then compare it to the alpha. Okay, so tell you, don't confuse. This p is not a proportion. It's not the same p, okay? It's not the same p, the lowercase p. It's the uppercase p is the probability, actually. The lowercase p is the proportion. And critical values, it's just the same definition. It's still separate the regions to the rejected region and the non-rejected region. So here, if this is the critical value, then, which means right side here is the rejected region. So it's the critical value just separate the whole region into two parts. Okay. The step 7, we could use either p-value method or the critical value method to get the conclusion, because these two methods always get the same conclusion. But our technical conclusion only can be reject none or fail to reject none. We will not say we accept none or accept alternative. We just say reject none or fail to reject none. So you can use this sentence to help you remember the rule. If the p is low, so here p stands for the p-value, okay? It's the capital letter p. So if the p is low, the none must go, which means we will reject the none. Okay, so p-value is very small, is low, we will reject none. So we can also say we get a significant result. So if it's greater than alpha, then we fail to reject. So the last step, we should restate the conclusion using non-technical terms. So because it can be understood by most of people. So that's the only reason we need to restate our conclusion. So we already know in our example, we reject our none. Remember? You still remember that? What is the test statistic we have? It's 2.55, right? Test and the p-value is 0.005. It's very small, less than alpha 0.05. This is use the p-value method. If we use the critical value method, we can also find the critical value here. We check the table to find the critical value. What's the critical value? In here, it's the z sub alpha, because it's the one-tail test. It's just the z sub alpha. So in this case, it's 0.05. We will find you will get this value in your z table. It's 1.645. So it's here. And you will realize your test statistic is 2.55, remember? 2.55. So it's right to this critical value. It will be located like this. Then in your graph, it's obvious it falls in the reject region, right? So we will say we reject it. Just like I said, we always get to the same conclusion by using p-value method or critical value method. This is the location of your test statistic. It falls in the reject region, right to the critical value. So I will give you another criteria to help you understand. If this z called critical value and this c with star called the test statistic, if test statistic has the greater absolute value, then we will reject. So this is another way to determine the result. Determine the result we should reject or reject by using the critical value. If our test statistic is greater than this one, absolute value is greater than the critical value, then we reject. If the critical value have the greater absolute value, then of course we will fail to reject. So check here. This one has the test statistic has the greater absolute value, right? 2.55 is greater than 1.645. So we will reject. So we go back to the non-technical form. If we already reject our none, remember what is our none here? We said none is equal to, p is equal to, right? If we reject this one, that means we think it's not correct. So we will maybe take the alternative one. So this is our conclusion. There is sufficient evidence to support the claim. This is our original claim. The majority of the customer are not comfortable. You understand? Because we reject our none. We take the alternative as our conclusion. Sufficient evidence to support the claim. Majority of the customer. Because proportion greater than 50 means majority. So the last one is just wording the final conclusion. So to help most of people understand your conclusion. So this table shows you the most of the case we can use this 4 kind of conclusion. So you can check it by yourself. So I would say we will not say accept, right? In your technical conclusion, we will just say fail to reject. So make sure you use the correct words to express your answer. We reject the null hypothesis. we fail to reject the null hypothesis. We will not say we accept the alternative. Okay, we will not say we accept the alternative. Okay, just avoid using the multiple negatives in your final conclusion. Okay, you should make your conclusion readable. Oh, okay. Confidence interval for the hypothesis test. We will say, we will just not recommend to use the confidence interval to do the hypothesis test. Okay, we will say confidence interval just for estimating, So we will not talk about it. Because the quick reason is sometimes the confidence interval method will not get the same conclusion as the critical value method or p-value method. But critical value method and the p-value method always get the same conclusion. Okay, for the type 1 error and the type 2 error, you only need to know a little bit about that. I would say maybe that's too complicated for you. So I would just say you only need to know the type 1 error, just called the significance level alpha. Okay, the only thing you need to know is this is the significance value alpha. It's the same one, same symbol, same one. It's just the probability we reject our true none. We reject the true none. The probability we reject the true none. So that's the I error. And the type 2 error is another type error. Is we fail to reject the false none. We fail to reject the false none. And you only need to know another definition related to the type 2 error, this one called power. So you think it over. If type 2 error is beta, what is type 2 error? Fail to reject none when none is false. Then 1 minus beta will be we reject none when none is false. So this one called the power of the hypothesis test. You only need to know the name. Not too much. I would say that's all. We can skip the remaining part. Okay, let's just stop here. So this section is just about the general basics about the hypothesis test. So later, next week, we will use the whole week just focus on the hypothesis test about the proportion. We will go over the step 1 to step 8 again. Okay, we will do the step 1 to step 8 over and over again. So make sure you can get familiar with the steps. Okay, the week after that, we will use another whole week to talk about the hypothesis test, about the mean. And so we will slow down because we have enough time to focus on the chapter 8. So, okay, let's just stop here.